Come back to Abbot of Code 2016 to in day 23. So I stop my recording on this one. So I'm just going to talk through it. Basically, this is a follow-up problem of the assembunny where we had instructions on a register and registers. So there's four registers, A, B, C, D, that each hold 0. And then these instructions can do some work, like copy values, increase, decrease, and jumps instruction away. In this follow-up puzzle, we have another instruction toggle, which kind of changes the instruction. So what we can do is make lines a mutable list, get the registers, go through the lines, and just apply the instructions as usual. Copy, increase, decrease, and jump not 0. I use this helper function to check if my input string is a number. If it's a number, then I just return the number. If it's not a number, then I check in the registers based on this being not a number. It's A, B, C, or D, basically, and I can refer to the register. Yeah, and then I add this new instruction, which basically just says, hey, check, toggle the row of argument 1. So I get the value of argument 1 if the argument is within the boundary, and I have to offset the argument by where I am currently, because I want to toggle the instruction like -2 away, means 2 away from where I'm now. So if that is valid, it's not smaller than the last line, then I update this line by toggling the line, and then toggling does similarly jump based on what it is. So increase becomes decrease, decrease and toggle become increase, gins become copy, copy becomes gins. Error for anything else, but I didn't run into any issues here. Then I can just run this. If I run this against the code, against the normal input, which is here, then it runs very long and doesn't really terminate. So there is a hint in, well, first for part 1, I put in 7 and it terminates. So I can just add the answer. For part 2, you actually put in 12 for register A and it doesn't terminate. And there's a hint here in the puzzle that we should use multiply instead of adding. So then you can look at the outputs and figure out that what happens here is we copy A to B, decrease B. Well, actually, you don't even have to go through the instructions. You can just run the program with a limited amount of times. Look at what the instructions are doing. And then you can see, okay, maybe a bit more. Then you can see after a while, there's definitely some patterns. So what happens is I copy A to B, right? So at the beginning, A is 12, and I copy B, so it's 12 as well. Then I decrease B, and I have 11, so I have 12 and 11. And C is 0 and D is 0. Then I copy A to D as well, so D. But yeah, we remember this, and then we start looking for patterns. Because we also copy B to C. And then what happens is, when we set A to 0, Then what happens is C gets decreased, with 9, 8, 7, and in that time A gets increased. So based on whatever B was, that many times A gets increased. And after C is 0 and A got increased now 11 times, then we decrease B. Basically, we want to 12, and then we do everything again. So it looks like we increase A 11 times again, then we decrease D. Then we increase A 11 times again, and then we decrease D. So what happens is we do 11 times, no, sorry, 12 times we do this. 12 times we increase A by 11. So if we go all the way back to the beginning, we just do 12 times 11. So basically all of these first part of the instructions are multiplying A by B. So we can replace all of these instructions with kind of placeholder ones because we don't want to mess around with the ordering here. Although I'm not sure, maybe we can also just mess around with it. I don't know, I think then copy minus 16C doesn't work. So we want to do nothing, but have the same amount of lines in the instructions, and then add one new instruction in the last place of the instructions that we are replacing, which is multiplying A by B. So we just do copy A to B, decrease B, multiply A by B. Then we implement the multiply A by B and update A by the outcome. And that basically gives us the result that we're looking for. So if I let this run, it should finish. So then it finishes, and that's the answer for part B. Thanks, everyone. Enjoy the rest of your day.